Welcome back. In this video, we're going to go over section 7.5, which is about a general strategy for factoring polynomials. So far, we've seen a handful of different methods for factoring polynomials, depending on the kind of polynomial that we're looking at. In this section, we kind of tie that all together and look at what if we're just handed some random polynomial, how do you do it? Let's take a look. So there's a kind of a set of steps to follow. First of all, you always want to check and see if there's a common factor that can be factored out. So that was kind of what we started with at the beginning of this chapter was common factors. So start with that. Factor out any common factors that you can. Factor out as much as you can. Once you've done that, count out how many terms are left. So for our class, it's going to be 2, 3, or 4 terms in all likelihood. For 2 terms, check and see if it's a difference of squares. If not, it might be a sum or difference of cubes. Sum or difference of cubes was what we just did recently. So if it's 2 terms, it's going to be a difference of squares or sum or difference of cubes. Notice that there isn't a sum of squares here, just difference of squares, sum or difference of cubes. If it's 3 terms, check and see if it's a perfect square trinomial. And if it's not, try either the AC method or trial and error if you like that. If it's 4 terms, or actually any even number of terms, 6, 8, if you happen to run across something that large, try factoring by grouping. So basically, common factors, count how many terms you have, and go from there. So let's try some examples. We're going to start with this one. It's 3a to the 4th power plus 18a cubed. Before thinking about how many terms there are, let me get that common factor out of there. 3 and 18, both divisible by 3. And also we can factor out an a cubed. If you factor 3a cubed out, you're going to be left with a plus 6. And that's it. There's nothing else to be done. Okay, 10a squared minus 17a plus 6. For this one, there's no common factor. There are 3 terms. So if there are 3 terms, the first thing to look for would be, is it a perfect square trinomial? And it's not. 10 and 6 are not perfect squares, so you can forget about that. So for this one, it will be trial and error if you like that, or the PQ grouping method if you prefer that. So I'm going to do that. So I need to find 2 numbers that multiply to be the same thing as 10 times 6, which is 60. And they have to add up to be negative 17. So P plus Q has to be negative 17. So thinking about that for a little bit will give you negative 12 and negative 5. 12 times 5 is 60, and 12 plus 5 is 17. So then we'll split that middle term into 2 terms. And then we can factor what's left by grouping. 10a squared minus 5a, we can factor out a 5a. And when we do, we'll be left with 2a minus 1. And then negative 12a plus 6, I need to... All right, let's try that again. So we're going to factor out negative 6 from the second term, and our second 2 terms, and that'll leave us 2a minus 1. Okay, now factoring out that 2a minus 1 common factor, we'll have 5a minus 6. Okay, and that will finish it. Okay, next we have x squared plus 36x. So first thing would be common factor. Here that's an x. So we'll be left with x plus 36. Okay, and that one is finished. 16x cubed minus 36x. For this one, there's a common factor of 4x that can be brought out. If we factor out our 4x, we'll be left with 4x squared minus 9. Double check by multiplying. 4 times 4 is 16. X times x squared is x cubed. Looks good. In the back, it also looks good. Okay. Now, what's left inside of parentheses? There are 2 terms. It's a difference, so it's either a difference of squares or difference of cubes. Here it's pretty clearly a difference of squares. So this will give us a pair of conjugate binomials. 4x squared, that will be 2x in the front. The 9 will give us a 3 in the back. Okay, and that does it. Okay, next, 4x squared, 20xy, 25y squared. For this one, there isn't a common factor, so I can forget about that. There are three terms, so I'm going to first check and see if it's a perfect square trinomial. The fact that it begins with a 4 and ends with a 25, which are both perfect squares, gives me some hope. I just have to make sure that that middle part works out okay. So that would be 2x squared in the front and 5y squared in the back. Then we should get 2 times 2x times 5y, and make sure that that part in the middle, in fact, works out to be 20xy. And it looks like it's going to. So we'll have 2x plus 5y squared. And that's it. All right, here's one for you to try. Take a minute, pause the video, try this one yourself, restart the video, and see how you did. Okay, so this one is we should look for our common factors first. I see 8, 16, and 24, so we should factor out that 8. We'll be left with x squared plus 2x minus 3. Okay, for this one, it's 3 terms are left inside. It's pretty clearly not a perfect square trinomial. So instead, I'm going to try to factor using the AC method here. The leading coefficient's 1, so it's easier. We need to find two numbers that multiply to -3 and add to 2. So that sounds like 3 and -1. So 8x plus 3, x minus 1. Okay, that's the end of that page. Let's see what else we've got. Just a few more examples. This section, there was not a lot of instruction with it, just going over that basic strategy and then a whole bunch of examples. All right, 81a squared plus 192. For this one, I want to check for a common factor. It looks like 3 at least will divide into those. Maybe we can do better than that, actually. Yeah, 3. So let's get 3 out of here. That will give us 21a squared. Sorry, 27a squared. And then 192 divided by 3, I think 64. Okay, so there's 27a squared plus 64. That was almost a sum of cubes. As is, that's finished. There's nothing else that you can do with it because it's a sum of, well, it's not even a sum of squares really. So that one is actually done. Let's go ahead and make a cube problem out of it just so that we have one of those to do. So let's make it 81a cubed plus 192. That'll make it a little more fun. So let's do that one. So here again, I would begin by factoring out of 3. This would give us 27a cubed plus 64. 3 is still out front. It's a binomial times a trinomial. It's been a little while since you did one of these, but hopefully we remember how it goes. Okay, so you should get 3a plus 4, then 9a squared minus 12a plus 16. Okay, so there's that. All right, so that's pretty fun. Next up, we've got 4m's to the 4th power minus 64. Once again, let me bring the common factor of 4 out. That will be m to the 4th power minus 16. Okay, so this one looks like a difference of squares again inside. So we'll look at this as m squared squared minus 4 squared. So this is a difference of squares. We'll have 4. This is the difference of squares. We should have a product of binomials. We'll have m squared plus 4 and m squared minus 4. That sum of squares, m squared plus 4, is not going to factor, but the m squared minus 4 in the back will factor as m plus 2, m minus 2. Okay. All right, so that will do that one. Okay, so this next one looks pretty fun. We've just got 2 left and we're almost done, okay? So for the next one, I should look for a common factor. So there's 16x squared, 24xy. See, 16 and 24 both are divisible by 8. In the back, it looks like we've got a 4 and a 6, so we could take a 2 out at least all the way across. Um, the There's no common factor all the way across for the letters. This one has 4 terms though, so it looks like it's one of those ones where it's going to factor by grouping. 16 and 24 both divisible by 8, as I said. 16 is 2 times 8, 24 is 3 times 8, 4 is 2 times 2, 6 is 3 times 2. So let's try just doing this one by grouping. This time I'm going to wait and not do the common factor first. I know I'm going against my own advice, but we'll take the common factor out later on. If you want to do the common factor first, go ahead. I'm not going to. So here, first 2 terms have a common factor of 8x. And if we factor out 8x, we should have 2x plus 3y. In the second 2 terms, I'm going to bring out a negative 2. Then we'll have 2x plus 3y. Okay, so now our common factor is 2x plus 3y. And then what's left is 8x minus 2. Now you can see in 8x minus 2 where we're going to get this common factor of 2 from. That if you did that at the beginning, you've already taken it out. So we'll have a 2 out front, 2x plus 3y, and then 4x minus 1. Okay, and that will finish it. Definitely want to take that 2 out at some point. Okay, next up, and this is our last one, we've got 4p squared minus 16p plus 12. So we're going to get that common factor of 4 out first. That will leave us with p squared minus 4p plus 3. Getting the common factor out of the way makes it easier to see what it is that we're dealing with. This one is just a little trinomial with a leading coefficient of 1. That makes life a little easier. So we're looking for 2 numbers that multiply to 3 and add to 4, same sign, both negative. So that sounds like p minus 3, p minus 1. All right, that will do it. That finishes up this section on strategy for factoring. Let me know if you have any questions, and have a great day.